So this week we're going to do some work with quadratics and word problems. Okay, so I wanted to give you this little keyword sheet to kind of help you navigate some of those questions that you're going to be asked when you're trying to figure out certain things about a quadratic function in a real world setting. Okay, I love this because it's when the quadratics actually become alive and you can understand how I'm actually going to use this in real life or how it can apply to a real world situation. So I think that's pretty interesting and pretty exciting. Okay, so the topics that you're going to see on this keyword sheet are things that are familiar to you already, things like the vertex. Okay, so we know that the vertex is either a maximum or a minimum of a function, right? So it's going to be like the highest place that something happens or the lowest place that something occurs. Okay, so if you're looking over here, it gives you like just little pieces of clues, little hints about what the vertex could be, how a question could be asked about the vertex. So we've got the x value of the vertex and the y value of the vertex, okay? And just to give you a little hint, a lot of times when you're doing these word problems in quadratics, the x-axis is going to represent time, okay? Not always, but a lot of times the x-axis in these word problems is going to represent time. So that's why you'll see this question phrased as when is the object at its maximum height? Okay, so when is asking you a point in time, all right? So if you're asked that question, when is an object at its maximum height, you know that you're looking for the x value of the vertex, okay? And then you can use what you know about the vertex in order to solve for x, right? It's that negative b over 2a, remember that? Finding the x value of the vertex. And then what if I want, well, so the y value of the vertex. A question might say something like, how high does the object get? Or what's the maximum height of the object? That's asking you for the y value of the vertex. Well, we can find that by first doing negative b over 2a, finding the x value of the vertex, then using the x value, plugging that into the quadratic function and solving for y, and we'll get the maximum height of an object at a certain point in time. Okay, the y-intercept, okay, this is something that we're familiar with already, especially if our function is in standard form. Because if it's in standard form, then the value of c is the y-intercept. So a question might say something like, how high off the ground did the object start? Okay, you may see a question that says something like, Billy stood on a platform that was 10 feet off the ground and he threw his teddy bear into the air. Now, I don't know why Billy would want to do that, but he did. Okay, so how high off the ground did the object start? Well, in that case, it would be 10 feet, okay? And then we have the zeros of the function, or also called the x-intercepts of the function, okay? So your x-intercepts, you're gonna have one that's gonna be on the positive side of your x-axis. You may have one on the negative side. You may have one that crosses at the origin, okay? So let's first look at the positive one, the positive 0. So what a question that it might ask you is, when does the object hit the ground? So when does the object hit the ground? Imagine this is something being shot up into the air, right? It's coming back down. And so at this point in time is when the object hits the ground, right? How long did the object stay in the air? Well, these two questions are asking the same thing. They're just phrased differently. So I want to know how long was the object lingering in the air before it hit the ground right there, okay? And we know how to solve for the zeros. We have 4 different ways we can do that. We can factor, we can do the square root method, we can complete the square, or we can do our all-time favorite, quadratic formula, okay? Let's look at this one over here that's on the negative side of 0. It says this 0 gets thrown out for being too negative. And what we're saying right there is that sometimes, like if you're getting your 2 x values and one of them is negative, let's say that your x-axis represents time, right? So if I get an X value that has a negative number in it, say like -2 seconds, well, that literally means 2 seconds before that item was launched or thrown or something like that. And that's not going to make a whole lot of sense in the context of our problem. So the negative times, we're typically going to throw those out. You're going to be focused on more the positive X values that you have right there, okay? So keep this sheet with you as you're doing your quadratic word problems, and you can refer to it and kind of match up the questions with this keyword little sheet right here, and I think that's going to give you some assistance in working those word problems.